This is a recording of me soldering together a USB Sanitizer. This is a prototype, so the final device will look slightly different. There's only a couple of modifications that I'm going to make between this prototype and the final version. I have the PCB already. I have all the components: ferrite bead, capacitors, resistors, LEDs, USB headers, the FTDI device, voltage regulator, resonator, and some headers. Three things go on the front: the FTDI device, the resonator, and the voltage regulator. All the passives go on the back, as well as the LEDs. And then last thing I'll do is I'll solder the USB headers on the ends. I will do my best to get this right. It's kind of difficult with a camera in front of me, but I figure this is the best perspective to get a decent video. First I'll do the FTDI chip itself. Next I'm going to do the resonator. It's got 3 pads in the bottom. I'm going to tin one of the pads in the middle to hopefully get a good contact. And then hopefully I can get the sides to attach well. Next, the voltage regulator. And that's it for the front of the board. I'm going to flip it over. I'm going to do all the passives. The way I like to do this is to tin one of the pads for every device, and then what I'll do is I'll slide the devices into their spots. That way the one side will keep it in place, and then I'll go back around and do the second side of every one of them. Try to keep consistent, so everything on the back of the board and the left side of the board I'm getting ready, and everything on the right side on the bottom, towards the bottom, I'm leaving. So 47 picofarad resistors, capacitors for USB. Just want to make sure that it's flat on the board, otherwise it's difficult to get the other end attached. (27 ohm) resistors for USB. These 27 ohm resistors are on the data line, so you'll notice there's 4 of them. 2 down here are marked do not populate. That's so that all you're doing is sucking power from the USB port. If you wanted to use this as a USB write blocker or add some other functionality, you could use that, populate those resistors and actually use it as a USB device as well as a USB host. Next. (47K ohm). Sorry. Yep, 47K ohm. These are some pull-ups. I actually forgot to order them, so I have tinier 0603 resistors that are smaller than the pads, whereas all the others are 0805. But I can make it work. Good enough. .7 microfarad. Never hurts to double check you've got the right one. Ferrite bead. 100 picofarad. 22 microfarad. And these are the LEDs, each one with a series resistor. They're hard to get because the board moves, because it's not flat. You can tell the polarity of the LEDs because the corner of them is a little bit green on the side that goes towards ground. And you can see there's a little dot that sticks out. It's like a T shape, and the middle of the T points towards ground. At least on these. Everything's attached. I'm going to go back and I'm going to solder the other side of every single one of those now. I'm doing a sloppy job. Some of these resistors are touching the LEDs, but there's actually a trace right there that connects the two, so I'm not worried about it. Now I'm going to attach the USB headers. I made a mistake and had to file off some little protrusions of the plastic because I forgot to put holes. The final version should have those holes, or I'll find a better USB header to use. This male end is just used for power on the USB Sanitizer because you don't want any data going there. And you can see do not populate at the end, that we don't connect those data lines. And these holes are a little bit big for these restraints, but I just load it full of solder and it holds well enough. I'll get the female end. Luckily the male and female headers are slightly different sizes, so you won't get them mixed up. They just won't fit. And I'll just fill this with a bunch of solder to hold it on well enough. And lastly, I'll put this header on. Probably don't want that on the final one. You can just hold it in place to solder it, to program the device. But since I'm going to be doing a lot of testing with this one, I'm going to slip this other board underneath so that the header is pushed flush in place. You might see that the holes are a little bit back and forth. That helps to hold the header in place, but doesn't completely do the job. Okay, I'll do the two ends. Okay. That's all the components. Shall we program it to see if it works? This is a standard FTDI cable. As of right now, power is on. I will just double check the voltage. And I get 3.3 volts on the regulator, which means everything's probably just fine. These two pins are the program pins. In order to program this device, you need to reset it while the program pin is held down. I'll probably have a better layout for this on the final one, but I'm clipping this clip to the housing, which is ground. I'm going to hold this little wire. I'm grounding both those pins, so the device is now reset. I'm lifting up so only program is held. So right now it should be in program mode, and fingers crossed. The device is flashing right now. It's verifying the flash. Done. So I should be able to, this is just a flashing light test program. Plug it in and 3 lights flash. I guess one of them didn't get soldered well. But that's how you build this device. You would just flash the USB sanitizing firmware instead.